Hi class, and welcome to another lesson. We're on 5-9 day 1. We're continuing this lesson on working with complex numbers. In this lesson we're adding, subtracting, and multiplying complex numbers. What's nice about this lesson is a lot of it is going to seem like review, because we're going to treat an imaginary number I like it's a variable. So a lot of the same rules and properties that go along with adding, subtracting, and multiplying variables are consistent with this lesson as well. Such as adding. When we talk about adding, we talk about combining like terms. So we can only add i's with other i's and constant with other constants. So we could only add 3 to other constants, which would be 2. 3 plus 2 is 5. And you can only combine i's with other i's. So 5i minus 4i is 1i. Same thing, 5 plus 1i. And this is our answer for problem number 10. Very similar if this were to be an x. If it was 3 plus 5x plus 2 minus 4x, it'd be 3 plus 2 is 5, and 5x minus 4x is 1x. So now we're just saying that the i's, we're now treating them as if they were a variable x. Looking at problem number 11, once again, we just take 6 and add 3, and we get 9. A negative 2i plus 7i, and get a positive 5i. Combining like terms, that's all this is. I want to take one moment, class, to discuss what standard form is for imaginary numbers. If you ever have two terms, a constant term and an I term, the constant term needs to come first. The i's always come second. So on our next chapter test, if you have 5i plus 9, I understand that that's the exact same thing, but I would count this incorrect because it's not in standard form for imaginary numbers. You have to have the 9 come first, and then the I come second, okay? So this way is not right. Make sure you write it in standard form. Number 12. Now we're subtracting, so we're going to distribute the negative 1. So it's 4 minus 6i minus 3 plus 7i. Combine like terms, and we get 1 plus an I. 4 minus 3 is 1, a negative 6i plus 7i is a positive I. Finishing up here with problem number 13 with adding and subtracting. Why don't you guys pause the video and try this one on your own. It's 5 plus 8i minus 7 minus 4i. So combining like terms, 5 minus 7 is a negative 2. 8i minus 4i is a positive 4i. Our answer for problem number 13, a negative 2 plus 4i. So now when we talk about multiplying complex numbers, again, we're going to do some of the same properties with variables as we would with complex numbers. The big difference here with complex numbers is we need to remember that I times I is I squared, and I squared is the same thing as a negative 1. So whenever you see I squared, it equals a negative 1. So now let's go through this one. We have a binomial times a binomial, so the process that we multiply these is foiling. First, outside, inside, last. So 6 times 6 is 36. And then we have plus 24i. Next one we have a negative 4 times a positive 6 is a negative 24i. And last times last, a negative 4i times a positive 4i is a negative 16i squared. So let's continue to simplify this. A negative 24i or a positive 24i minus 24i is 0 i's, so the middle two terms are gone there. So these are what are called conjugates of each other, right? 6 minus 4i, 6 plus 4i. Whenever we have conjugates, the middle terms always cancel out. So now we have 36 minus 16 times a negative 1. This I squared right here becomes the negative 1. And a negative 16 times a negative 1 is a positive 16. So it's 36 plus 16. So my answer for problem number 14 is 52. When I multiply those two imaginary binomials by each other, I get the number 52. Problem number 15. We got to be very careful, class. Some people, they just go like this. They say 8 squared is 64, and a negative 11i times negative 11i is a positive 121i squared. This is not correct. When we have a binomial and we square it, we got to remember to FOIL. So it's going to be 8 minus 11i times 8 minus 11i. Make sure you remember that. So 8 times 8 now is 64. Here is a minus 88i. Inside term is a minus 88i. And the last times the last is a positive 121i squared. So now let's combine like terms. 64, a negative 88i minus 88i is a negative 176i minus 176i. And then this is the same thing as I squared. Or this is I squared, which is the same thing as a negative 1. So a positive 121 times a negative 1 is a negative 121. And then finally, let's combine 64 and a negative 121 to get a negative 57. A negative 57 minus 176i. There's the answer for problem number 15. Why don't you guys pause the video and try number 16 and 17 on your own. Try 16 and 17 on your own. Here's what you should have got for 16. When you FOIL, you got 8 minus 20i plus 6i minus 15i squared. So then you got 8 minus 14i plus 15, because a negative 15 times a negative 1 is a positive 15. So for our final answer, 8 and 15 make 23, so it's 23 minus 14i. 23 minus 14i. Again, class, make sure you do not have a negative 14i plus 23. This is not standard form, so make sure you don't write it like that. Write it like this. And then for 17, hopefully you got this. 7 times 9 is 63. Minus 42i plus 18i minus 12i squared. And a negative 12i squared is the same thing as a positive 12 because it's a negative 12 times a negative 1. So for our next line down, we're going to get 63. A negative 42i plus 18i is a positive 24i. And then we had this positive 12. A negative 12 times a negative 1, positive 12. So for our final answer for problem number 17, 63 and 12 make 75 plus 24i. There's our answer for problem number 17. And lastly, problem number 18. We're going to have the distributive property twice here. Once there, a second time there, and then we're going to combine like terms. So negative 4i times I is a negative 4i squared. I times a negative 8 is a negative 8i. Plus 6 minus 24i. Let's combine like terms here. This right here becomes a positive 4 because it's a negative 4 times a negative 1. So a positive 4 plus the 6 here is a positive 10. And then a negative 8i minus 24i is a negative 32i. And there's our answer for problem number 18. 10 minus 32i. So again, to summarize, treating an I is a lot like treating a variable when we multiply, add, and subtract. The big difference is that when we multiply, an I times an I is I squared, and I squared is the same thing as a negative 1. Let me know if you have any questions on that when you get to class tomorrow.